Now, moving on, the next topic is about Powertrain Dyno System. 刚才 Dr. Uday Deshpande 有提到 Powertrain 的部分，那么这部分的 presentation 同样也是 Dr. Uday Deshpande. Second presentation from Dr. Uday Deshpande. VCR.
Greetings, everyone. Welcome to this presentation on e-motor testing from DNV Electronics. My name is Uday Deshpande. I'm the CTO of DNV Electronics, and while I wish I could have been there in person, I'm happy to share this presentation with you. We'll talk about electric motor testing. I'm sure you're all familiar with electric motor testing. Cover everything from basic confirmation that the assembly and manufacturing is done well, to performance, to being able to start studying faults and issues so that you can verify design and performance, and then down the road durability effectively. So the various tests listed over here I'm sure are familiar, but we'll get into that in the subsequent slides a little bit as well. Moving to the broad solution, then again largely should be familiar. You've got a motor under test. This shows the e-motor driven by an inverter, which is fed by its DC supply, which could be a battery emulator, so that especially in the electric vehicle space, you want to be able to mimic the traction battery behavior. And then you have a dyno motor, a load motor, if you will, that has its own drive panel. Now, recirculating the power at that level helps to reduce facility power that would be required that comes from the master control panel. In addition, then you have your data acquisition system that that allows you to capture torque, speed, position, voltages, currents, temperatures, etc. Data that allows you then to analyze various parameters as well as performance indicators that you're interested in. Now, the system over here, the data acquisition system here is developed as along with the rest of the system internally by DNV. It's purpose built for dyno testing. Can handle up to 10 megahertz sampling frequency, certainly in bursts. As you can imagine, 10 megahertz will generate a ton of data, and so for applications that require it to be bursted, otherwise the sampling stays at a more reasonable rate for the testing that is being done. The dyno is capable of going up to 30,000 RPM, and then it has got a unique design layout that we'll talk about in just a little while later, that you can see some of the benefits that the system has to offer. Now, I won't necessarily go into the details of the test, but I'm sure you're familiar. You do a high-pot test to make sure that there is no insulation problem, so that you can make sure that the device under test is actually harmonious and should be able to be tested. Similarly, you do winding resistance test, a standard 4-wire Kelvin measurement method to make sure, again, there is no issues coming out of manufacturing and assembly. No cuts, no open circuits, no short circuits, etc., or incorrect number of turns and so on, so that, again, verify that the motor is suitable for running the rest of the test. Once you have that, you start getting into some of the additional tests, back EMF tests that allow you to check voltage amplitude, amplitude imbalance, voltage phase imbalance of voltage, all of them again to verify that the motor is within expected design parameters. Beyond that, you do position sensor check, make sure the position the sensor installation is correct. If you've got a resolver, you do a transformation ratio test to make sure that you're looking at the right performance over there, and then that ensures again that the position sensing information will be adequate for running the test. Similarly, to make sure there's no other manufacturing assembly issues, you can run things like friction torque tests, so that you can verify that everything is again running smooth. And all of these, if it's an end-of-line test, you can run these connections or make these connections automatically. We'll talk about that in just a little bit. You can generate reports automatically, so that once the results are done, you can get quick indicators of pass or fail if that's the case, or data to do further analysis. Moving on to things like a lock rotor test so that you can start looking at the subtransient reactants. Again, verifying design behavior versus also looking at this for subsequent use if needed for controls development or controls tuning as well. Then you go into the performance test, and the performance test covers a gamut of things, running from discrete points to profiles to just automating the system. As you see, you can create profiles or sequencing of tests so that you can run the whole test in automated manner, gather all the information, and then run the analytics to get torque, speed, voltage, power, efficiency, all the good stuff that one looks for. Beyond that, you start doing coast down tests to make sure that there is no other issues like mechanical issues, eccentricities, bearing faults, seals, and so on. Before you allow the unit to move forward. Similarly, a free run test allows you to do the same thing. Now, here's the thing, right? The back EMF test, the coast down test, the free run test being done after the load testing can be done automatically by being able to disengage the spline so that you're able to do these tests without having to stop everything and redo some significant mechanical rearrangements to run the different tests. So having done these tests, one of the capabilities that we offer is a noise and vibration, or sound and vibration test, actually, perhaps a better term, to provide another view of looking at the health of the motor. Now, this can be run without need of an anechoic or semi-anechoic chamber, and gives a good qualitative indicator in case of potentially any faulted conditions that might exist. Now, this requires a training of the system with a series of known good, known bad motors, such that the signatures are collected, which is then used to determine whether or not the motor under test passes or fails. And done properly with adequate amount of sampling, the artificial intelligence algorithms that are used and applied to the sound and vibration measurements, we've seen that you can detect fault almost 100% the time, and then with a success rate of over 97%. So a good tool to have especially during your end-of-line testing, to provide an additional insight into problem motors, and potentially could be done early as well, just to make sure that before you spend a ton of time running tests, we have a known acceptable motor to run performance tests and so on. But typically this is done, not always done. Some customers choose to do it, some customers don't because of the training time involved. So, but it certainly is a feature and capability that is offered as part of the dyno system. So, as I mentioned earlier, if you want to run all those tests, that entire test sequence can be programmed. So everything from HiPod test to the free run test, including performance tests, could be done seamlessly. You saw the scripting tool that allows you to do that. This could be set up by us or some standard profiles, or the customer can create their own profiles based on their requirements and their knowledge of their system. So this automated test not only allows you to run the test, but it also includes DUT setup, connections, connecting to power, mechanical attachment, and so on, especially if this is being done as an end-of-line test as part of the general manufacturing flow. We won't get into that, but what you see is that we've got motor test systems that cover small units, 50 Newton meters, or smaller in terms of 70 kilowatts all the way up to 300 kilowatt, typically used on tractor systems. And again, the two broad categories are used for R&D or for production, end-of-line production tests. So a degree of automation of how you actually hook up the device under test is primarily the difference between the two units. Beyond that, we talked about this dual load motor system. One of the unique features that that DNV developed is instead of developing a 20,000 RPM dyno motor, we are able to use two relatively standard off-the-shelf motors with a unique patented pulley and spindle system that allows the test motor to be operated up to 20,000 RPM. And then, as you can see, it provides flexibility in terms of being able to get things off the shelf. Typically, lead time tends to be smaller. You can tune the torque speed curves that you need based on suitable motor pulley and spindle designs. So if known, you can actually configure this and then change out configurations to be able to run, say, for example, passenger vehicle or e-motor testing. You can even do an e-axle testing depending on the nature of the e-axle by, again, suitably changing the pulley and spindle design. Having done that now, so all of this obviously works under a software suite. Again, this software suite was developed internally, again, purpose developed for testing on the dynos. Again, probably the capability allows for using either standard scripted setups, or the customer engineers can create their own test scripts, test profiles, test programs. It gives you full flexibility of being able to incorporate testing the way the customer wants to test, right? CAN Wizard allows you to do dynamic mapping of the DUT signals for multiple purposes. The CAN message fields that allow you to, again, interface with third-party development tools if you need. You got manual or automatic modes of operations, as well as we talked earlier, you get some sound and vibration additional capability that can enhance your insights that you can get from the test. I won't again go through that line by line, but the measurement software and the display software provide typical characteristics that you need: plotting, scoping, chart recorder, spectrum analyzer. The system actually uses PLC-based safety systems. Then you can look at equipment health indicators. There are user access script editors, formula report generators. So all the capabilities that one can expect such a test system to have, we provide that capability with the flexibility of being able to use define your own testing structures or use some of the standard ones. And of course, we are happy to help develop for you if you need to. CAN connectivity, we just talked about this briefly. The CAN messages connections to the DUT allows you to look for any communication issues, debug modes, and then allows you to connect to third-party hardware. So, for example, thermal chambers and so on and so forth, a lot of those things can all then be managed centrally through this capability. We talked earlier about the SV Pro analysis tool. This just gives you a little bit more of an insight. You've got the traditional analysis of a signal, spectrum analysis, amplitude, spectrograms, etc. You can do automatic detection and diagnostics along with deep learning. So when you combine the two, it gives the capability of providing some additional insights into the a good or a bad part that may or may not be detected through some of the other tests. And it just offers a really alternate way of being able to get some good qualitative insights. This just gives you a quick example of the SV Pro. There's several e-motors that were provided. You had known healthy, known faulted conditions. The signatures that were captured and analyzed then allowed SV Pro to be trained to ensure that any other motor that is being sent for testing can be checked for, let's say, typical problems that one might expect within your system. And so again, the customer has got some flexibility to say that, okay, you've got bearing problems, so ensure that we are able to catch bearing problems. If there is some kind of rubbing issue that happens periodically, then check to see if we can train the system to capture those issues. And so again, in a relatively simple setup without a significant amount of invasion of the primary purpose of the motor test system, you can generate these additional insights of the motor that you're testing. So with that, hopefully, you have a sense for some of the capabilities of motor testing that DNV provides. You have the contact information of our sales team over here, and I'm sure they'll be happy to provide a lot more information. And of course, you can reach out to me if you have any questions on the system. So with that, I'm going to stop and look forward to future discussions with anybody interested in learning more.
Okay, thank you. From DNV CTO Dr. Uday Deshpande 一连谈到2个 system 哈 ，inverter test system 还有 powertrain dyno system。